Hi everyone, this video is on question 5 of exercise 9F PO2. So we have a very typical question in differentiation, which is about finding the equation of the tangent to the curve at a specific point. For part A, we need to differentiate the given function y is equal to 1 over cos x times sin x. Before we differentiate this, we can use trigonometric identities to simplify the function and then differentiate that, because that makes the differentiation much quicker and easier. So we need to remember the identity that sine 2x is equal to 2 sine x times cos x. Now here, if you look at the denominator is cos x times sine x. And then looking at here, as you can see, we have sine x times cos x, but this 2 term is a bit annoying here. So we just need to get rid of the 2. And the way we can do that is simply by dividing both sides by 2. In that case, we'll have sine 2x divided by 2 is equal to sine x times cos x, which is exactly the same as the denominator. So this allows us to write the function as y is equal to 1 over, and instead of cos x times sine x, we just write down sine 2x divided by 2, which is equal to 2 over sine 2x. And we can simplify this further, because 1 over sine x is equal to cosec x. So in this case, this should be sine 2x, not sine x. Yeah, so 1 over sine 2x is cosec 2x. So in this case, we are going to have 2 cosec 2x. And as you can see, we started from y is equal to 1 over cos x times sine x, and we got to this point, which is 2 times cosec 2x. Now at this point, we can use the standard results that we learned in this section in order to differentiate 2 cosec 2x. So divide dx is equal to, we just need to remember that if we have cosec kx, the derivative is equal to minus k times cosec kx times cot kx. So that's the standard result that we learned in this section. So in this case, it also has a minus at the beginning. So sorry if I didn't say that. So minus kx times cosec kx times cot kx. So in this case, this 2 is already there. And then the derivative of inside, which is 2x, is 2. But again, it just has a negative. That just, when we differentiate cosec, that gives us a negative derivative. And then for the rest of that, it's just basically rewriting that cosec 2x times cot 2x, which is equal to minus 4 cosec 2x times cot 2x. Okay, this is the answer to part A, which is finding the derivative. Now for part B, we need to determine the number of stationary points of the curve C. Again, whenever we want to find the stationary points, we just need to set the derivative to 0 and then solve that. The solutions give us the x coordinates of the stationary points, or a stationary point. Sometimes there is only one single stationary point. So in this case, the derivative that we found is minus 4 cosec 2x times cot 2x is equal to 0. We can divide both sides by minus 4, so we only have cosec 2x times cot 2x is equal to 0. And we can now solve this equation. So there are 2 possibilities, or 2 cases. The first case is when the first function, remember this is just a typical type of equations when, for example, we have something like 2x times e to the x is equal to 0. In those cases, we say either 2x is equal to 0 or e to the x is equal to 0. So this is exactly the same type. So because we have the product of two functions equal to 0, so one of them has to be 0, at least. So in this case, we say either cosec 2x is equal to 0, or cot 2x is equal to 0. Now we can solve these ones, and also just remember that the question says determine the number of stationary points. So we are not asked to explicitly solve the equations. As long as we can determine the number of solutions, we don't need to write down the full solution. But we will get there because there is one more step before that. So the first equation, cosec x is equal to 2x is equal to 0. So there is a big problem with this one, because what is cosec? First of all, let me show you here something. So cosec x, for example, is equal to 1 over sine x, right? And if we say this is equal to 0, we are basically saying 1 over sine x is equal to 0. And the problem is that this is undefined. So you can't have a value here that you get the value of the cosec as 0, because we can't have 0 in the denominator, or we can't have anything that makes the whole thing 1 over something equal to 0. So the thing is, yeah, cosec 2x is equal to 0 doesn't have any solutions, because it just, cosec doesn't have the it doesn't happen in cosec that you give a single value and then that returns 0. It just doesn't have a solution. So that's the first thing for the first equation, I mean. But for the second equation, it gets interesting, because this actually has solutions. Cot 2x is equal to 0, and if you solve that, remember that the values of x are between 0 and pi. So since it's 2x, we multiply each of these by 2, and we get 2x is less than or equal to 2 pi, and then the equation is cot 2x is equal to 0, and then you can say cot inverse of 0. So this gives you the values of pi over 2 and even 3 pi over 2. Obviously this continues, but that's enough for us, because that's in the range that's in the domain that we have defined. So we just divide everything by 2, because we want the value of x, pi over 4, 3 pi over 4. Also, as I said, we didn't need to explicitly solve the equation, but I guess that's probably the most straightforward way in this case to say how many solutions we have. So yeah, basically we have 2 solutions, so that means we have 2 stationary points for the curve C. And finally, the last part, it says find the equation of the tangent at the point where x is equal to pi over 3. And also we need to give the answer in this form. So you should be very familiar with these types of questions. We just need to find the gradient and then use the equation of the straight line, and of course finding the y coordinate of the point, because the point has the x coordinate of pi over 3. So let's find the y coordinate and then the derivative at that point, and then find the equation. So for the first step, we want to find the y coordinate of the point when x coordinate is equal to pi over 3. So in this case, all we need to do is that we just go back to the function y, and just remember that this is what you have. This is a simplified version. Of course, you can go and use the original version. So yeah, we just need to substitute the value of x, which is pi over 3, into here, and then that gives us the y coordinate of the point, which is 4 root 3 over 3. So the point, let's call that P, is pi over 3, 4 root 3 over 3. The next step is finding the derivative. Again, when x is equal to pi over 3, the derivative is equal to, so It's just the same thing. So if you want to find a derivative at this point, you substitute pi over 3 into the equation of the derivative, which is here. So here you substitute pi over 3 to find the derivative, which gives us the value 8 over 3. And now we can use the equation of the straight line to find the equation of the tangent. So y0 is just the y coordinate, which is 4 root 3 over 3. M is the gradient, which is 8 over 3. And finally x0 is pi over 3. The only thing is that we just need to give the answer in the form ax plus by plus c is equal to 0. So we have some additional steps of rearranging this. We can multiply everything by 3. 3y minus 4 root 3 is equal to, so 3 cancels out with the denominator, and we are just going to have 8. So 8, and then expand that, 8x minus 8 pi over 3. And for the next step, in order to have a nicer form, we can multiply everything by 3 one more time, because of this 3 in the denominator. So we will have 9y is equal to 9y minus 12 root 3 is equal to 20. 4x minus 8 pi. And finally, we just need to rearrange that. So 9y minus 24x minus 12 root 3 plus 8 pi is equal to, and this is the final answer. So this is the equation of the tangent at the point pi with 3, 4 root 3 over 2. Okay, thank you for watching. I'll see you in the next video.